is all being led by a group called the Smart Ships Coalition, which is a group of technology, academia, research, private industry, other interested parties who are really focused on developing and cultivating and sharing technology and advancements in the Great Lakes, with a common interest to advance and protect the Great Lakes. So with me today, I have Travis White. He's a research engineer at the Michigan Technological University, MTU. He's in the field right now. He's on a vessel, they call it a chase vessel, which is collecting data, but it's also following an autonomous surface vessel, also known as an ASV. You can think of it like a robot that's out there by itself collecting data, looking for the wreckage of this plane.
That's right. So we're on scene here. We've got a 21 square mile survey area set up. We're doing survey lines that are about 7.5 miles in length, parallel to our shoreline. And our search area is in about 300 to 400 feet of water depth. So fortunately, we've got very nice conditions out on the lake right now, and we're able to get these lines done at a pretty good speed, collecting very good data.
Why was this area chosen for this 21 square mile area for the search? What sort of led to the conclusions of this location?
Yeah, so we looked at a lot of historic information, including Coast Guard reports, vessel logs, Civil Air Patrol logs, where wreckage was found, or currents and the wind was doing at the time of the accident, and sort of pinpointed this area as the most probable for finding debris from this aircraft.
How many aircraft are believed to be missing or crashed in the Great Lakes?
I have record for at least a little over 1,100 aircraft of all variety that have gone down into the Great Lakes. Very many of them have been found, and very many have been recovered, but there's still quite a few that are still missing. Probably several hundreds are still missing.
I've got a whole crew of technologists on board. James and Chad from Ocean Infinity behind me. Chad is currently working on the line planning for the next part of the ASV survey. And Anthony's to my other side, and he's observing our Norbit multi-beam coming from the ASV. So this is live in real time. And what we're doing is we're looking for reflective targets and unusual features on the lake bed and this backscattered data that's being collected from the multi-beam instrument.
So in addition to the actual features on the bottom that we're searching for, we can also see a lot of very interesting topography on the bottom. And I can interrogate that a little bit further by actually doing things like a cross profile and being able to see some of the changes in the lake bed bottom. And this is really useful in a real time sense, because as Travis and others are out there, searching, looking for targets and such, then they can very easily be doing this interrogation to make decisions and to help them decide if they found something of interest. Can all have access to this display. So really a truly group or team effort to be able to monitor the progress of the survey and make decisions about what's going on.
And then behind me, I've got my colleagues, Jessica and Ali from Kongsberg, who are operating a different multi-beam system, 2040, on this vessel, pole mounted. So we're running parallel survey lines, kind of divide and conquer in what we would call a force multiplication scenario with the ASV.
Mounted up on the top here, this kind of looks like a popsicle stick or a surfboard. This contains two GPS antennas that receive satellites from both GPS and from GLONASS. Then the cables come down here and then connect down through this hole back here to both our sonar. They connect to our sonar and to our motion reference unit, which helps figure out how the vessel moves, its heave, pitch, roll, and yaw. And the transducers down there, which is what is making the sound and listening for the sound to come back to get a better picture of the seafloor.
Now, as you can see, there's a lot happening on board the small chase boat. We've got our ASV. You can see the lake conditions are quite still at the moment. And we've got a smaller chase boat out with us today, so they're tending to the ASV right now. And behind me here is the control station for this ASV. You can imagine to collect all this data, it's a very time-intensive process, and the ASV really helps automate part of that. Normally the same crew that's on this vessel would get half of the survey done in a day that we're getting done today, because of the fact that we have this ASV that is running a parallel mission plan to us.
Yeah, that's great. Fantastic. And what many people may not realize, I'm sure you do, because we're part of Lakebed 2030 together, only 15% of the Great Lakes has actually been mapped in high resolution. And we're part of a team that's trying to map the entire thing. But we know that's going to cost about $200 million and take about 10 years. So this little part that you're doing right now is really important, because not only are you searching for the missing plane, but you're adding to this large database of high resolution data that will be able to now generate new maps of the Great Lakes, which is really exciting for not just this mission, but the larger mission of Lakebed 2030 as well.
We've found a lot of interesting features in the sonar data. We see a lot of geological features in the lake bed, some of which include sand waves that are propagating kind of perpendicular to the shoreline behind me out towards deeper water. And some of these sand waves are, maybe 15 meters, 40, 50 feet in height as we come up and over them. So we're seeing a very dynamic lake bed. And we're also seeing in the most recent transit lines here, or survey lines rather, we're seeing a lot more reflective, rocky, hard features. And that's obviously making it much harder to pick out what we're looking for, which are small, reflective objects such as aluminum wings or airframe structures. So we've got some good promising targets. We're doing the investigation, but certainly won't have a definitive answer to that question just yet. So we're hoping to answer that soon. Wayne is currently with my colleague Christopher Pinot and Ryan Williams. That group is in a smaller vessel, and they have on board a remotely operated vehicle. As we're going along looking at the sonar data in real time, we're picking targets that look resemble potential debris or parts of a man-made object. And we're providing those coordinates to that other vessel. And their job right now is to go over those coordinates and investigate closer. So the process gets more and more time intensive for each target that we investigate thoroughly. But for now, we're kind of looking for those high likelihood of being a piece of debris from this aircraft. And we have a few targets that are interesting, but it's hard to say without sending down that next piece of technology. Any wrecked aircraft is treated very much similar to a wrecked vessel in the Great Lakes. It is it's a part of the state bottomlands. It won't be disturbed. It won't be moved. It would not be recovered. However, what we're trying to do is document its location and condition, and try to provide as much of an answer as we can to that question of what happened, while preserving that wreck and that debris in the current condition we find it. We're on transit, and it's going to be a great day.